So now we're going to put the tensor in TensorFlow. A tensor in TensorFlow is just a way of storing data. And I assume if you're doing deep learning, you probably know machine learning and you've worked with NumPy arrays before, and it's exactly the same thing pretty much. The thing about tensors is that they're optimized specifically for deep learning, so they're a little more efficient. And one of the biggest benefits of using them is that they can run directly on a GPU. Normally, with regular computer programs, it just runs on the CPU, and that's fine. It can do well on that. But with tensors, you have these data structures, right, that hold lots of numbers, and they can get pretty big, and they can have multiple dimensions and all that, right? And then you're going to be doing these math operations on these tensors over and over and over, and doing that kind of stuff is not very optimized for a CPU. But a GPU can support faster computation because a GPU can support many more parallel operations since it has many more cores than a CPU. And I think that's very interesting. Like back in the day when they created the GPU, obviously that stands for graphics processing unit. They used it for graphics, obviously, but then people found out that they can also use it for stuff like deep learning or machine learning, and it's much more optimized for that than using it on the CPU. So when you're using TensorFlow, it'll automatically detect if you have a GPU available, and if you do, it'll do these tensor operations on the GPU, so it runs, faster, right? That is one of the biggest benefits of using tensors, which is really cool. Another one that we'll learn about in just a little bit here with tensor variables is that TensorFlow can automatically track the change that happened to these variables, and then at the very end, you can have it automatically differentiate and get the gradient of everything that you just did. So we'll talk about that in a little bit, but it's just really cool. Now that we know what a tensor is, it can just store information like a NumPy array. Let's go ahead and start using it. So we're going to import TensorFlow as TF. Now to create a tensor is very simple. We can do scalar is equal to tf.constant. And then to this, we can pass the value of our tensor, which is going to be 3 for us. So this is a scalar value. So scalar, it's going to have a rank of 0. And the rank is just simply how many dimensions or how many axes you have. So dimensions or axes, I don't know, but I'm going to say axis. So that's the meaning of rank, how many dimensions or axes you have, okay? So if you want to, you can have a vector as well. So you can have a vector, which is going to be rank 1. And a vector can be made by doing vector is equal to tf.constant. And then just like a NumPy array, you can provide it as just a list here of values. So we can do 1, 2, 3, and that's it. So now we have a vector tensor that just has the values 1, 2, 3 in an array. And this is rank 1 because we have one dimension. If you want to, you can also print these out. So we can do print scalar, and then we can also do print vector. Let's run this now. And here we go. This is what it looks like when you print it out. So tf.tensor. So this is going to be the actual value of the tensor. This is the shape, and it's just empty because this is a rank 0 tensor, so it doesn't really have any shape because it's a scalar value. And then we have the d type, which is the data type, which is int32 by default for a whole number. And then our second tensor here has the list of 1, 2, 3. It's a vector behind the scenes. And so it just has a shape of 3. And we'll talk about shape in just a second here. And the data type is int32 as well, okay? So that's how you can create a scalar tensor and also a vector tensor. Let me just show you real quick how you can create a matrix, because that's also a very popular thing that you need to store. So we're going to do a matrix, just say rank 2 tensor. So we're going to do matrix is equal to tf.constant. And we can think of a matrix as, of course, a multi-dimensional array. So that's how we'll pass it in. So we're going to have a top level array, and then inside of that we'll have 2 sub-arrays. So we're going to have 2 rows, right? And then we're going to have 1, 2, and then 3, 4. Okay, so this will be a 2 by 2 matrix, so it'll have 2 rows and 2 columns. Hopefully that makes sense. So we can go ahead and print that out now. Matrix like that. And boom. So now we get the first 2 tensors, and then we get our new tensor that represents a matrix. So how do you know that it's a matrix? Obviously, if you just look at it, this is pretty simple to understand that it's a matrix since it's a multi-dimensional list. But if we actually look at the shape here, this tells us all we need to know. So you can read the shape as, first of all, how many numbers there are. How many numbers there are determines the rank, right? And we know the rank is the number of dimensions or the axes, right? For the first one, we have no numbers, so it's a rank 0. If we have 1 number, that's rank 1, which is a vector. And then for the new one, we have 2 numbers, which is a rank 2 tensor, so we know that's going to be a matrix. So that's how you can determine the rank or the number of dimensions, which also tells you what kind of data it is, pretty much. But also the numbers themselves, like 3 or like these 2s here, will tell you how many values are in those individual dimensions, okay? So for the second one here, for the vector, we see that it only has 1 number, so we know it's a vector or rank 1 tensor, but the number 3 tells us that there's only 3 values in that dimension, so 1, 2, and 3, that makes sense, right? If it was 1, 2, 3, 4, we would have 4, okay? Hopefully that makes sense. And then for this one here, we have 2 numbers, so we know it's a rank 2 tensor, but then the numbers is 2 and 2, so we know that on the first dimension, there's 2 values. As we can see, there's 2 lists, right? So that makes sense. And then the second number says 2, so that means in the second dimension, there's also 2 values. and that lines up with each sublist having 2 values, okay? So for example, if I was to change it to be like 1, 2, 3, and then 3, 4, 5, or something like that. Now, if we rerun this, we should get 2 and 3, okay? So this shape checks out. We know it's a matrix still, obviously, also because it only has 2 numbers, so we know it's a rank 2 tensor. But also, if we look at the numbers here, we see 2 for the first dimension because there's 2 lists or 2 rows in our matrix, you could say. But then also we have 3, which is the number of columns in our matrix, as well as the number of values in the second dimension, okay? Okay, so this documentation on the TensorFlow website is actually really good. It tells you, so it says the shape is the length or the number of elements of each of the axes of a tensor, which I just explained. The rank is the number of tensor axes. So if a scalar is rank 0, a vector is rank 1, and a matrix is rank 2, that makes sense. That's the number of dimensions. And then we have the axis or dimension, which is a particular dimension of the tensor. That's self-explanatory. And then the last one is the size, which is the total number of elements in the tensor, the product of the shape's vector elements. So if we just sort of take this matrix and flatten it, so it's just one vector, it would just be 1, 2, 3, 4, 5, 6. That would be the size of our tensor that we have here. Okay, so hopefully that's all making sense. And then of course, one more example here. We can have a higher dimensional tensor. We'll just call this one just tensor is equal to tf.constant. And this one can be, higher than rank 2. It can be rank 5, it can be rank 3. So if we just want to do rank 3, we can do that. And here we go, I'll just paste it. So this is a rank 3 tensor. So we have these brackets at the very top, and then within that we have a sublist, and then within each of those sublists we have another set of 2 sublists as well. So if we print this out, we should get more explanation on what this is. And yeah, so we have a shape of 2, 2, 2. So since there's 3 numbers, we know it's a rank 3 tensor, meaning that there's 3 axes. And then for each of the axes or each of the dimensions, we have 2 values each or 2 elements each. So although tensors with higher rank than 2 are harder to sort of visualize because they're higher dimensional tensors, these are actually more common than you would think. For example, a rank 3 tensor can be used for something like RGB images. So for example, you have an image with a height and a width, and then for each of the elements of that image, each of the pixels, you have an RGB value. So that's another 3 values per pixel. So that sort of lines up with a rank 3 tensor, okay? And then if you have multiple images, that would need to be multiple of those, so then you would get a rank 4 tensor. So you can just expect our tensors to have a bigger rank than 0, 1, or 2. So sometimes you may have a tensor, you don't really know much about it. So just printing it out will give you a little bit more information about it, like the shape and the data type and stuff like that, which is very helpful. You can also just directly print out the shape if you only want that, because usually the shape alone tells you a lot. So there we go, we get 2, 2, 2, just like that. Hopefully that's all making sense. Now we have a way of storing data, and hopefully you notice that we're calling .constant, and this implies that a tensor is a constant, meaning that it cannot be changed. And that's true. So once you create these tensors like we're doing here, once you have given it an initial value of like 1, 2, 3, for example, that cannot change, okay? In the next episode, we're going to learn about variables, which are tensors that can change values essentially. Now, I told you guys before that tensors are basically like NumPy arrays, and that sort of makes sense, I think, if you look at how we work with them and look at the shape and all that stuff. But we can also easily convert between them, which is really great as well. So we could do like import numpy as np, and then we can start doing like, for example, scores is equal to numpy array, and then we can pass in a 1, 2, 3, for example. So that's what it looks like. And let's just say that we want to make a tensor out of this so that we can use it to do some sort of deep learning stuff. It's actually really easy. So we can just do tensor is equal to tf.constant, same as before. And all we have to do is just pass in our numpy array, and then it automatically converts that into a tensor for us. And boom. So now we get 1, 2, 3, which is our numpy array. But then after that, we print out our tensor. So tf.tensor, 1, 2, 3, same values. We got our shape, which is 3. And the data type was set to int64 automatically for some reason. One other thing that you can do when creating these tensors is also specify the data type. So by default, when you do these just regular whole numbers here, it should be int32 most of the time. But if you want to, you can do dtype, and you can do something like tf.float32, and that will specify it to be a float value. So if we print this out, now we get our same tensor as before, but you can see that there's a decimal number now because it's a float, which is just a floating point number. You can also do, I think, float 64. There you go. So it's just more precise, takes up more memory. You got int32. But yeah, this is useful because you may want to specify some numbers for your tensor, but then also you want them to be converted to a specific type because for deep learning, at least, a lot of the time you're going to want your numbers not as whole numbers, but as floating point numbers because neural networks, for example, like to work with floating point numbers. So it makes sense to actually have your values as floating point numbers. So if you're bringing in a data set and you're converting it to a tensor, for example, you want it usually as a float 32 type. You can also notice that the data type was brought in as a int64 data type for some reason. I don't know why it's 64 and not 32. Maybe that's because it's a numpy array. But so if we want to, we can do dtype is equal to tf.float32, just because, like I told you before, a lot of the time you're going to want floating point numbers and not just regular whole numbers. So here we go. So now we can see that before with the numpy array, it's a whole numbers. But then when we bring it into TensorFlow as a tensor, we can see that's 1 point, 2 point, 3 point, and the dot just means it's a floating point number, okay? So that is how you can take a NumPy array and convert it to a tensor. But if you want to, a lot of the time you're going to want your values just as a regular NumPy array, and you can do that easily just by taking your tensor and doing .numpy, and that will convert it to a NumPy array. So boom. So before it was a whole number, then we brought it into TensorFlow as a float, and then now since we're outputting it back to a NumPy array, it's still going to be a float, but now it's back as a NumPy array, which is awesome. So let me show you guys some more ways you can generate some tensors. So we can do tensor again is equal to, we can do tf dot, and now instead of constant, we could do, for example, zeros. So we can just get a tensor filled with zeros. And all you have to do to this is provide the shape of the tensor that you want. So shape is equal to, and then in parentheses, you can do like, for example, 2, 3. So this will give you a rank 2 tensor, right? Because there's two numbers. And then for the first axis, you're going to have 2 values. And then for the second axis, you'll have 3 values. Okay, so let's try this out. So we're going to do print tensor. And boom, so now we get a tensor. And you can see that it has all zeros, which is perfect. You can also notice that it's also all float 32, which is great. We can also do tensor flow.ones, and we can specify the shape as something else like 3 and 2 instead of 2 and 3. And now if we print this out, we should get a bunch of ones. So now it's a different shape, still a rank 2 tensor, but it's filled with ones. Perfect. One other one that you can do is tensor is equal to tf.fill. And then now for this one, instead of specifying the shape, you can specify the dimensions, the dims. So we can do 2 and 2. And then now we want to tell it just what value we want to put. So we can do values equal to 5.4, for example. Let's make it 4 by 4 actually. So it should be a 4 by 4 matrix. So print this out. And boom, now we have a matrix here. You know it's a matrix because how it looks and also the shape again. But you can see that each of the elements of the matrix have the value 5.4 because that's what we told it to fill it with. So awesome. So those are some more ways that we can create tensors, just filling it with different values like zeros, ones, or a specific value. You can also generate random tensors or tensors with random values by doing tensorflow.random.normal. So it's a normal distribution. Specify the shape, so 3, 2, print it out. This is what we get. So just a bunch of small but random numbers. You can hover over it to tell you exactly what that means. So outputs random values from a normal distribution example that generates a new set of random values every time. So you can read into that if you want to. You can also do a uniform distribution if you want to. So the shape, the minimum value, and the maximum value. And here we go. So that's what that looks like. Okay, so I know that's a lot, but now we're done with the different ways that we can create tensors. Now I'm going to show you guys some of the mathematical operations that we can do on tensors, because basically all of deep learning behind the scenes is really just operations on tensors. So these are some of the basic ways that you can do these operations, okay? All right, so if you just have these two tensors here, A and B, they are both vectors filled with 3 values. So 1, 2, 3, 4, 5, 6. They're both float 32 data types. So let's just say we want to add them. We can do C is equal to tf.add A and then B. So this will be an element-wise operation, meaning that it'll just add each element to the other element in the list. So it'll basically match up the shapes and add the corresponding elements to one another, which hopefully makes sense, okay? All right, here we go. So we get a new tensor because, of course, tensors are immutable. They're constants, meaning that when you do an operation, it just outputs a new tensor for you to access. So that's tensor C, and we can see that it's still the same shape, of course, same data type, but now we have different values, which is 5, 7, and 9, because we've added 1 to 4, 2 to 5, and 3 to 6. Pretty simple, right? Very, very easy. Now we can also do subtraction, so C is equal to tf.subtract A and B. So now we get -3, -3, and -3. The next thing is element-wise multiplication. So just like before, it's going to add or multiply each element by each element. So C is equal to tf.multiply A and B. Print out C. And boom, so now I get 4, 10, and 18. Very simple again. And then another very common operation is matrix multiplication, which is essentially the dot product. All right, so we're gonna have two 2x2 matrices here. So 1, 2, 3, 4, 5, 6, 7, 8. We're just gonna multiply them. And then now we can do the matrix multiplication or the dot product by doing C is equal to tf.mat mul A and B. So instead of multiply, it's gonna be matmul, so matrix multiply A and B, and print out C. And then from this, you get a new matrix. So Hopefully that makes sense. And the difference between the matrix multiplication and the element-wise multiplication is that the matrix multiplication is not element-wise, it's happening across the columns and the rows. The number of columns of the first matrix must match the number of rows in the second matrix. So if you don't know how the dot product works, make sure you read into that because it's very important for what we're doing here. So those are some of the most common tensor operations that we can do. As you can see that when we do these operations, we're getting new tensors, right? And we're just printing them out, at least for this example here. But a lot of the time you want to actually access the underlying values of the tensor, the actual numbers themselves, right? Or the elements. So what you can do is, again, just convert it back to a NumPy array. So we can do c.numpy, and this will give you the underlying matrix instead of wrapping in a tensor. So if we rerun this now we only get the actual list itself, which is great. Okay, moving on, we're almost done here. So the next thing that I want to show you guys is accessing elements of a tensor, because sometimes you want to extract certain parts of a tensor, and I think that's very important to understand how to do. All right, so we've got a 3x2 matrix here. We can, print out the shape if we want to. So tensor.shape, 3x2. And then let's just say that we want to access the first element of this. We can do that really easily by doing print tensor 0. And I think that makes perfect sense, right? So the 0 is obviously going to be the first one. So getting the first one of this here will give you the first element, which is the first row. Okay, that's pretty self-explanatory. But then if you want the first element of the first row, it'd just be 0, 0. So you're accessing that sublist. So now this gives you the first element of the first list of the entire list, but that's as a tensor, a scalar tensor, right? So again, if you want the actual value, just convert it to NumPy, and that will give you the actual number. There we go. And of course, if you want the second one, you change the first one to 1. So now you're getting the first element of the second list of the entire list. If for some reason you want the first column of the matrix and not just the first row, you can do it a little bit differently. So you can do print tensor, and then inside of here you specify first the rows that you want. We want all rows, comma, and now we only want the first column, so we'll do 0. So print that out, and there we go. So now we get 1, 3, 5, which lines up with 1, 3, and 5. If you want the second column, change it. Now we get 2, 4, 6. If you want the third column, you get an exception because there's no third column, okay? The last thing I'm going to show you guys is how to reshape tensors. So here's the same code that we had above. If we just print this out, it's still the shape of 3 and 2 if we print the shape. But if we want to, we can reshape it to 2, 3. So reshape to 2, 3. We can do reshaped tensor is equal to tf.reshape, pass in the tensor that you're trying to reshape, and then the actual shape that you're shaping it to, 2 and 3, like that. And then now we can print reshaped tensor, and boom. So now we have a reshaped tensor. The shape is now 2, 3, like we wanted it to be. And now the values look like this. So it's 2 rows and but 3 columns. Before it was 3 rows and then 2 columns. So behind the scenes, TensorFlow just knows how to rearrange the elements in the way that you want it to be. So one actually common use case of this is sometimes you'll have a vector tensor. So TF.constant 1, 2, 3. It's a simple vector, so it's a shape of just 3. But sometimes you want your vectors as a matrix, so then you can do matrix multiplication. So an easy way to convert your vector into a matrix is by doing matrix is equal to TF.reshape, and then vector. And now to reshape this vector into a matrix, right now it's just the shape of 3. So that's just, a vector with 1, 2, 3. But we want to represent as a column vector, which is a matrix that's 3 by 1. So 3 rows with each of the values of the vector, and then just 1 column for those values, okay? So that'd just be 3 and 1, just like that. And boom, so now we get 1, 2, 3, but as a matrix instead of just a vector. Okay, so that's actually it. I know that was a lot. That's probably longer than it needed to be, but now you guys should know and should be comfortable with working with tensors for, it's TensorFlow, so you should know how to use tensors, of course. Y'all should know what it is. It's just a data container very similar to NumPy arrays. They can easily be converted to and from NumPy arrays, which is great. They can have different ranks, which is just the number of axes or dimensions. So you can have multi-dimensional data, which is great. Very useful for machine learning, of course. You also know how to generate tensors with just filler values like zeros, ones, or just a specific value. You also know how to create tensors with random values, so a normal distribution of values or a uniform distribution of values, which is very useful. But then I also show you guys how to do math operations on these tensors. Notable is the element-wise multiplication and also matrix multiplication, which we'll be using. And then, of course, accessing elements of a tensor and then reshaping tensors. So all of that is very important. Hopefully you guys understood all of that. Just like always, make sure you check the description below for the notebook so you can see all the code, okay? So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.